A very warm welcome to all of you. Myself Rajan Choudhary, Professor in the Department of Civil Engineering, Indian Institute of Technology, Guwahati, instructor for the NPTEL MOOC course, Pavement Construction and Technology, funded by Ministry of Education, Government of India. Today's lecture will be under the module 8, where we will discuss the aspects related to the quality of bituminous bound courses. At the very beginning, I would like to acknowledge the use of text, information, graphs and images sourced from various textbooks, codal standards, journal articles, reports, newsletters and public domain searches. Now, as we have already discussed in some of our previous talks, that inflexible pavements bituminous bound courses forms a vital role specifically, and they are widely used in the construction of bituminous bound base courses, bituminous bound binder courses and bituminous bound wearing courses. So, these are the three typical layers in which these bituminous bound courses are used. You have bituminous base course, bituminous binder course and bituminous wearing course or the surface course. And where you have this one specifically, the binder course is the one which comes in between your surface course and a bituminous bound base course. During while discussing these aspects, we will refer to different codal standards, textbooks and various other methods and sources, including some of the important ones which are there specifically followed in India. You can see we have the specifications for road and bridge works, MORT is 2013. We have the IRC SP 112 manual for quality control in road and bridge works. Similarly, you have many IRC standards, like this is the one standard for standard specifications and code of practice for prime code and tech code. Then we have IS 73 for paving grade binder, IS 15462 for modified binders. So a good number of standards exist specifically to look into the quality aspects of bituminous bound courses. Now, as we discussed in the previous lectures also, that we need to understand that there is going to be a certain amount of variability which is going to exist in the various road construction activities. So, it is to be recognized that road construction, like many other manufacturing processes or construction processes, has certain amount of variability inherent in the materials, methods involved and due to testing, sampling also. So, therefore, prescribing acceptance criteria in absolute terms, the important part is if we are checking a density, if one result fails and then you say no, this lot is to be rejected. So, that in terms of absolute terms is not recommended. So, therefore, prescribing acceptance criteria in absolute terms such that an entire section of a construction or a batch of a material is rejected on the basis of a single substandard sample. So, one test result should not be considered the only reason behind rejecting an entire lot work. So, this is important and would be both impractical if we are doing it, it will be impractical and it will be prohibitively expensive also. So, may not be accepted also. So, because of the inherent variability, the aim of quality control is to limit the variability. Yes, what you can do, wherever the sources of variabilities are there, that can be limited. So, first of all, one needs to figure it out during a bituminous mix production, what are the sources where some variability are possibly to take place, where the chances are high of any variability to exist, and then certain measures can be taken to reduce that variability, so that the final product is what you desire or what you want to obtain. So, a philosophy which has been mentioned by William Edwards says, if you improve the quality, it helps us to decrease the cost because of less rework, fewer mistakes and delays, snags, etc., and the productivity improves. So, this particular one, the quality checks are very important for any particular course, and when it comes to bituminous bound course, since these are the courses which are going to take the maximum loads, these are the courses which are the main structural components of your flexible pavements. The checks and the controls have to be much better for specifically these courses. Now, as we mentioned in the earlier lectures also. Here we will discuss one particular aspects related to quality control charts. What it says, analysis and evaluation of test results should be carried out continuously. It should not happen that once the work is done, completed, one day work, and then some checks have started. No, it should be a continuous process. So should be carried out continuously during the progress of a bituminous work, so as to have a desired acceptable final outcome and construction. Then only you can expect a product as per your requirement. So during the entire process there should be continuous monitoring or a check which is to be required. An effective method for monitoring quality during construction is the use of the control charts. Now this is one effective method which is widely used specifically in bituminous bound courses. And what are these? What control chart gives you? Control chart provides a simple and efficient means of a graphically representing the quality control data, which may be of a particular characteristics. So, a quality control data for a particular say bituminous mix characteristics and facilitating its further analysis. So, that helps us to analyze that particular data, and that helps us to understand if there is some variability and what is that variability, because of what reasons it is happening, that can be figured it out, and we can take some measures to reduce that variability. So, control charts may preferably prepared in the form of plots, where we can these are the plots, say individual test results, or it can be a running average. So, we can previous 4 readings can be averaged, and then this can be, so this can be a running average also of test results. Now, here you can see, if I am putting up upper specification limit and I am putting up a lower specification limit. So, this is here it is an example of the density of a compacted bituminous core. So, I have put a range that I need a density in the range of 92 to 96% of our maximum specificity. Now, here I can see how the test results are varying. So, if I see the test numbers are shown and this one. So, I can figure it out that the test results are in this particular range, they are consistent. Then there was some variability which brought them. So, this because this check of density is, if it is done at the field, then I can here give some during this course of period I can analyze that there is continuously some fall in there and the density is approaching towards the lower specification limits. So, then I can give some information or instruction there at the paving site that you need to take care in terms of your rolling or compaction efforts or the paving operation from the paver, because there some initial compaction is done by pavers also. So, then I can see again some improvement has happened. After certain period again there has been some particular one. So, I can figure it out that at site something is happening which needs a control to reduce this variability, and I will always target to have it in the middle of this particular range which is given to me. So, this is how I can get a good idea about. Now, this compaction, this variation in compaction may not be only because of rolling, because there may be some variability in the mix which is coming up. So, there may be some segregation in the mix which is so when there is segregation, the density will be lower in that case. So, we can, so then in that particular case we can do this check for the density in respect to the other control charts which may be with regard to the aggregate gradation. So, I can have a control chart where I am looking for the variation in the aggregate gradation when it is getting produced at the mix. So, from there if there is some change in the aggregate gradation, then for the same rolling pattern and the same number of passes, the density achieved may be different. So, it may not be. So, by seeing the control charts for other parameters, I can see where the variation is happening, because of which, and then I can figure it out, okay, the measure has to be taken for this particular activity so as to reduce this variability and bring it towards my target specifications. The inclusion of control charts in the quality control plan is recommended for effective process control. As I mentioned that there is a effective process control can be done by using these control charts, as measurements of various attributes of bituminous mixes are recorded. and the results are plotted on the control charts along with the considering upper and lower tolerance limits can be there. So, this gives you, as I mentioned, any particular characteristics in this particular one. I can see, okay, here this is going along the center line, the target ones, they are in this particular one. So, I can figure it out with respect to the control charts of other characteristics what has been there, and then I can pass an instruction and some measure has to be given up, so that it can be brought back and this to this our center line. So, this is what is important. So, this is a continuous information, this is a continuous progress has to be checked, so that we can rectify it during the course of construction itself. So, these charts provide a clear visual representation of the process performance and its conformity to the specified requirements. Some of the key benefits of using control charts includes early detection of potential problems, because see, this is in the field, there at the hot mix plant itself, I can look for this particular one at the gradation of the stockpile also, because the source of the stockpile, if it has changed, then particular one, then its gradation may change. Then when it goes to the cold fill bins, from there through the gathering conveyor, when it goes for the production plant, so there may be some changes, some segregation may be happening at the cold bins. Then when it goes to the plant, in case of batch milk plant, when it goes to the hot screens, if those screens are not properly working, then also this particular, there may be chances that some aggregate gradation is changed. So, where I need to figure it out at different stages, control charts for different materials. Specifically what we have in bituminous mixes, we have aggregates and binder. So, aggregates gradation is the one which is important. So, if I have to control the aggregate gradation, I need to control it at various points. Then I need to look into my binder. Binder, specifically my binder content is important, how much binder content is getting incorporated. Then finally, when it goes in the field and is laid there, then the paving operation is there, rolling operation is there. So, at the paving operation is some segregation is happening at the screeds of the paver, or the rolling pattern is not good enough to have a uniform density. So, from my, if I am finding my earlier that gradations is coming out to be good enough, binder content is coming out to be good enough, that means there is certain challenges or some issues which are happening while it is getting say transported either, or it is laid and compacted. So, accordingly measures have to be taken up. So, some of the key benefits of using control charts include early detection of potential problems, reduced variability, this is very important, lower inspection frequency. Once you have a lower variability, you can very well figure it out that you will get a uniform mix, and minimized risk of rejection or price adjustment by the owner. This we will discuss later on. Pay factors are there, if because of any reduction in the quality or reduction in the performance of the final product, if some price adjustment or has to be done, then also that can be figured, we can figure it out. But the important thing is to reduce the variability during the course of production itself. Now, testing asphalt mixtures during production is essential and ensures a durable and satisfactory product, because this is what very important is there. For hot mix asphalt construction, key properties and test results evaluated and monitored through control charts during manufacturing and placement may include, what are the things which can be monitored through control charts? One is aggregate gradation. Now, in aggregate gradation, you have different number of sieves, maybe 7, 8, 9 sieves may be there. So, certain sieves are always considered as critical, maybe it by 3 by 8 inch sieve is the one, your 200, the number 200, that is 75 micron sieve size is always considered as a critical one. 2.36 mm is considered as a critical one, which bifurcates coarse aggregates and fine aggregates. So, you can select some of the critical sieves and then look what is the percentage, what was the percentage derived in your job mix formula, and what you are actually getting at different parts of placement or at different places during the production process. Second important thing is binder content, because it plays a significant role in the performance of bituminous mixes. Then we can, once this is there on the compacted mixes, we can determine the volumetric properties simultaneously, because as the bituminous laying is going on, the mix is getting compacted simultaneously. You can look for the compaction of it. You can even similarly, you will prepare the samples at the laboratory setup at the plant also. So, from there also you will work out the volumetric properties, and especially what volumetric properties are considered. This is voids in mineral aggregates, air void content, and theoretical maximum specific gravity. Now, strength, along with it on compacted samples, strength and flow are the other characteristics. Density of laboratory and field compacted, that is in field also we measure the density, we can do the determination in the lab also. Monitoring these properties with control charts help ensure consistency, reduce variability, and maintain the quality of asphalt mixtures throughout the production and the placement. So, this is what an important aspect. Now, we will discuss some of the aspects related to aggregate gradation. See, although several aggregate properties are important, because we have discussed various properties in terms of the shape, impact, strength, polishing characteristics, adhesion characteristics, but one important is the gradation. So, if all those physical characteristics are ensured, then then that particular source, because we will look into the specific what the gradation is there. So, for quality control and assurance, samples can be collected. Now, from where do we collect the samples? This is again an important part. So, this aggregate gradation can vary from source, at what location we are collecting the samples. So, from where we can collect during the production, from the key points such as the stockpiles which are there at the hot mix plant, cold filter belt which is there. So, your gathering conveyor is there which collects the material from all the cold bins, from there you can collect it. Hot bins in case of batch mix plant, since the screens are there, hot is elevated screens are there. So, there those screens separate it out. So, from there we can collect this particular one, or from once it has been loaded in a tipper, from the loaded tipper we can collect, or from the behind the paver, or specifically when it is dumped in the hopper. So, from various places we can collect the bituminous mixes, or specifically the aggregates alone for determining the gradation. One can say always I will prefer to check when finally it is there going towards for the laying purposes, but yes, that is, but before that, if you are finding that the final mix is having some different gradation compared to your job mix, you need to know that where it is happening, whether this is happening because of some changes in the stockpile gradation, it is happening because of the misfunctioning of the your inadequate functioning, improper functioning of the your cold bins, or it is happening because some of the screens of those hot elevator screens, hot bins are not working properly, where this particular one is happening, or the dust collection system or the introduction of dust is not proper enough. So, those things needs to be looked into. Evaluating gradation at multiple stages helps identify where variability occurs. This is why it is required, enabling quick troubleshooting. So, we can quickly, okay, this is the place where it is happening. So, what measures has to be taken? If it is happening at cold bins, we will look what rectifications are required at the cold bins level. So, the aggregate gradation in the asphalt mixture is most critical as it represents the final product. However, controlling gradation at earlier stages is essential to ensure that it finally meets. So, this is what during the process itself, production process itself, we can look into it. Now, as I mentioned, what can be there at the stockpiles. So, these different stockpiles are there. So, once the initial stockpile gradation is established, because while doing the job mix determination, the combination proportioning, we will look into the stockpile gradation. This can change specifically if some new materials are added to it. So, then definitely the stockpile gradation is going to be changed. Otherwise, what variations can be possible? It is because of some aggregate source change, the source of the natural rock which was used is different. Segregation during the handling or stockpiling, how you are putting up the aggregates, how it is coming up from the crushers conveyor belt and falling it out. So, there that particular some segregation and take place, and also how do you sample it. If I collect sample at the bottom of my stockpile only, and or if I collect only from the top of my stockpile, I will get segregated aggregate particles. So, this is again another concern. At cold feeder, now when it comes to the cold bins, and through that particular one we have the gathering conveyor which is there. So, since combined aggregates are fed into the HMA plant from the cold or the cylinder conveyor, the cold feeder conveyor or the cylinder conveyor, after the screening of the heavy the bigger size particles, checking gradation at this point can be quite useful, because then I can collect from this gathering conveyor, because this is what finally entering into the plant. So, if that is entering as per my requirement, it is good enough. So, variations may arise from inconsistent stockpile gradation. So, the control chart may show whether stockpile gradation is going out or not, or from aggregates segregation which may be there in the cold bins itself. Improper loading or incorrect settings. Improper loading, you fill it, there is a overfilling of these cold bins, and whatever the opening the settings means the opening or the settings of the auxiliary conveyor from which the material comes from the individual cold bins, that needs to be adjusted along with the sampling and testing errors. Similarly, when it comes to the hot bins, which are specifically there in the case of batch mix plant. So, there what may be the possible reasons for this particular one? Improper cold feed gradation. If there is the gradation coming from the cold bins is improper, then definitely what will have hot bins will also be improper. Inconsistent dust collector feed. This is important, because what the dust which has been collected from your collection system, which is your primary and secondary collection system, how it is getting fed back to this aggregates, that is important. Production rate changes normally, because this happens if the production increases or there is change in the production rate, then the screening efficiency gets changed. So, this is another aspect. Screen defects, if some of the defects arises in some of the screens, then also this may be, and sampling and testing errors are there. So, then when it comes to the loose mixes, so once the mix is produced in a batch mix plant from the pug mill, or it is the continuous production from a drum mix plant, there specifically what may be, now as we move ahead, all earlier steps will be having a contributing factor. So, it may be at the mix level, it may be because of cold feed bins, or it may be due to incorrect hot bin proportions, which will be there in case of batch mix plants, inconsistent dust collector feed which is there, aggregate segregation within the plant, within the dryer in that particular one in case of drum mix plant, segregation during storage, and yes, thereafter it may be stored in storage silos before finally transported. So, if we are collecting after that particular one, there may be some segregation may be happening at the your storage silos also. Transport, laying and sampling errors. So, I can work it out with the control charts where actually my variability is happening. And then you have these standard tables which have been specified by our Indian Roads Congress guidelines as well as the MORTH specifications to compile the information. Now, after the aggregate gradation, the another important parameter is your binder content, which plays a very important role specifically in the performance of a bituminous mix. If there is a mix with a lower binder content, then it may have some durability concerns, because this is the one which is specifically required for giving it the resistance towards moisture induced damage, giving you the desired resistance towards cracking, fatigue. So, if it is the binder content is inadequate, there will be concerns related to the durability, and if the binder content is also in excess, then also it may results into challenges associated with rutting, as well as rutting where the deformation is there, and bleeding when the binder comes over the top. So, that these kind of concerns may arise if the binder content is more than what is designed. So, the binder content significantly affects the mixture properties, and since these are the performance affection, how the performance will get affected. Along with it, we have, since in terms of volumetrics, it will play a significant role. It will change the asphalt film thickness, lesser binder content, the lesser will be the film thickness over the aggregates. Volumetric properties, specifically voids in mineral aggregates, air void contents gets affected, and the stability also. So, this is very important to monitor asphalt content during the course of production of bituminous mixes. So, now at HMA plants, improper, what can be the causes for an say this variability in the asphalt content, specifically at a hot mix plant, because of inaccurate aggregate or asphalt content scales. Because like in pug mill, where their wave hopper was there, how much content, how much weights of individual sizes of aggregate has to come up, and how much content of binder has to come up. So, if those scales are not working properly, you will get some inadequate asphalt content. Leakage may be there in that particular case, continuous dropping may be there, coming out of the binder may be there. Segregation specifically may happen in case of batch plants if the segregation is there, because if you have coarser aggregate particles, then since they have lesser surface area, so you will find binder content in that particular mix, the binder content may appear to be more compared to a finer mix if there is some segregation. Or from inaccurate belt scales which are there, specifically miscalibrated asphalt meters are there, because the asphalt meters also needs to be calibrated, and incorrect moisture corrections may be also there, specifically because, as I mentioned, normally we go for the drying and heating of aggregates. Depending upon the capacity of plant, normally we are able to address moisture contents from 2% to 6%. So, sampling or testing errors can further contribute to this variation in the binder content. Now, once finally the best part is we are able to pick up the mix once it is loaded in the truck. So, once that is there, we can determine, there are specified methods through which we can determine. One is the centrifuge extraction method, very widely used, where a solvent is used and that solvent extracts the binder from that mix. And second is the ignition oven method, where it is the binder is, the mix is heated to high temperatures so that the binder is completely burnt. So, these two are widely used methods specifically, and what are the advantages is this method is you are able to get the aggregate with you, and for on which you can determine the gradation also. So, you have determined the binder content and you can work it out on the determination of the aggregate gradation. This is how an ignition oven looks like, which burns off the binder, and the binder content is determined as the weight loss which is experienced, whereas in the other one, when the binder solvent is filtered and the aggregates are separated out, normally the solvents are hazardous one. So, nowadays this ignition method is also preferred. Non-hazardous solvents has also come into picture. This is how a centrifuge extraction is there. This is where you use this binder and solvent and you separate out this the binder which is dissolved in the solvent from your aggregate parts. So, then you get the binder content, how much is the binder content you are actually getting in a mix. Now, in addition to, you need to know the volumetric properties also, specifically the volumetrics, as well as after compaction you need to have the compacted characteristics also, which is in terms of your strength, Marshall stability and flow and density. So, for dense graded, specifically under volumetric properties, one characteristic which is very important is the air void content, and other simultaneously measured is the voids in the mineral aggregates. Coming to air void content, usually dense graded mixes are designed to have an air void content in the range of 3 to 5% or 4 to 6% in some cases. So, this is the usual range, 3 to 5%. Now, you need, because here you have a upper specification and a lower specification limit. Why? If air void contents go below 3%, then there are chances of rotting and bleeding, performance related concerns, If they are above 5 to 6%, then it may lead to premature aging, because the oxidation is chances of oxidation is more, which can lead to raveling, cracking and stripping. So, these are again performance related challenges. We will discuss about these distresses in our upcoming lectures. So, where we will talk about raveling, cracking, stripping. So, these are stripping when the binder film gets stripped from the aggregate, cracking when cracks are observed on the surface, raveling when you see that the fines are lost from your bituminous surface. So, that is raveling. Marshall stability and flow should meet mix specification, that is because for different mixes and with different binders the requirements may be different for your Marshall stability. So, that particular mix should meet those requirements, and specifically we need to see into it, because a very low stability and high flow may have a mix which is prone to rutting, because that shows that the mix is soft enough, and while an over stiff mix may be prone to cracking also. A mix which is very stiff may crack when it gets deflected under the traffic load. Now, to compare these volumetric properties of compacted mixes, we need to know the maximum specific gravity, that is theoretical maximum specific gravity of the loose mix. So, this we normally sampled when we have these trucks in which the loose mix is loaded. So, from here we will work it out the theoretical maximum specific gravity, and then we will compare the density obtained in the lab or in the field with the theoretical maximum density, and normally it is said that the density should not be less than 90 to 93% of the theoretical maximum density. So, the mix in the field should be compacted to a density more than 92 to 93%, but there is an upper limit also. It says it should not go more than 97% in most of the cases, because there then the air void content will get reduced than 3%, then again some concerns related to rutting and bleeding will start. So, this is a particular range. We will prefer to have the density of a compacted mat in the range of say 92 to 97% or specifically 92 to 95%. Now, if this density is less than this particular one, that is the air void content is more than this particular one. So, in that case the mixes are more prone specifically to raveling, oxidation of binder will be there, that mix will be prone to the stripping also. So, this should not exceed in that particular case air void content more than should not be more than to 7 to 8% also. So, the constructed pavement should not exceed a density specifically either 96% or 97% of the theoretical, because we target to look for an air void content after 2 to 3 years of service life around 3 to 4%. So, this is if it is initially during the laying and compaction, only if the density goes below 3 to 4% and the air void goes below 3%, then the chances are that the mix will show certain failures with related to the rutting. You can see a depression which is shown along the wheel path. So, this can happen in a newly constructed bituminous course. So, this is again a table shows where how the information can be recorded for different parameters, how the results can be plotted, and we can continuously, where you have the percentage bitumen content, stability, flow value is there, VMA is there. We discussed these ones during the bituminous mix design. So, considering these different parameters, usually there are certain parameters which are widely preferred by pavement technologists specifically to monitor the process, out of which the one which is most commonly preferred is the density and the binder content. Thereafter followed by aggregate gradation, air void contents in compacted Marshall specimens, voids in mineral aggregates, voids filled with the asphalt, stability and flow of compacted Marshall specimens. So, these are the important parameters which are usually considered, and the first two are the most widely referred one. Now, here comes now this particular one, another aspect we can look into this particular one, as we discussed in the previous lecture, that we can look for the distribution of the results of these different parameters. And as we mentioned that a normal distribution curve for different attributes is usually used to compute two parameters which we mentioned. There was one was the percent within limits, this is PWL, percent within limits, and other one is percent defective. These are the two parameters which is there. What is percent within limits? If the results are plotted using your standard deviation and mean, and if I see and if the limits are shown, so percent within limits indicates the percentage of the lot conforming to the specification. So if this is the plot of my results of say 5 to 7 number of samples, then I can see, and if this is my specification limit and which is a lower specification limit, my test result should be more than this one, then this is what the area under this particular curve where I am meeting my requirement. So, this if I work out this particular area, I will get how much percentage of results are within the limits. So, this is what the percentage within limits, and this is what below this particular one will be my percent defective. So, indicates percentage of a lot falling outside the specification limits. So, there can be a single limit, as I mentioned, we can have a single limit if it is in terms of some density or in terms of binder content, or we can have a range. We can have a lower limit as well as an upper limit, and then I look to see how much is there my within the lower limit and upper limit. So, this will be my percent within limits, and sum of this one and this one will be my percent defective. So, this is a criteria for, so this can be in case of binder content where say we allow a variation of plus minus 0.3%, my target is 5%. So, then this will become 4.7%, this will become 5.3%. So, I will ensure with respect to this one where my results are actually falling. So, once this is there with both the percent within limits with respect to the percentage defective of a lower limit, percentage defective with respect to the upper limit, and there can be certain parameters which may have only one limit, either it may be upper limit or a lower limit. So, I can work out the percent within limits as if in case of one limit it can be percentage defective either lower or upper, and with two limits it is the 100 minus percent defective up with upper limit and considering the lower limit also. So, this is for, and on the basis of this particular one we can work it out the pay factors. This is specifically is generally the percentage of contract cost which can be paid. So, for 1 day's work we can work it out this particular one on a lot to lot basis. It should not be once the entire project, it should be lot to lot, because as we will do this monitoring continuously. So, for quality allocation, now this is a typical example which has been shown here. It is mentioned that pay factor, this is the percentage of the contract cost which can be paid. So, it says 55 plus 0.5 into PWL. So, percentage within limits, if I can say that my what should be the percentage within limits. So, if 90% is within limits, then in that particular case this will be 100%. So, I can make a 100% payment. This is a typical example, because I understand therefore there will be 5% variability. So, I have to realize and consider this variability while making the payments through the contract. So, due to inherent variability in materials, production, construction and testing, some test results may fall outside the specification limits. As I said, 5% may fall out of it, or lesser than that may fall, but yes, definitely this is a normal phenomenon that some test results may fall out of your ranges. So, this is expected and not necessarily, and 1 or 2 test results falling outside is not detrimental. So, that is what we are checking through these percent within limits and percentage. For example, a 90% limit, percent within limit, as I mentioned, will work out to a pay factor of 100 in that particular case. These pay factors are developed on the basis of experiences which we have with our mixes, our conditions of construction. So, depending upon, this is one example taken from some other countries. So, there can be this particular one. Similarly, we can have pay factors for our particular projects also, and this may depend upon the size of the project also. So, percent within limits based payment systems account for both penalties and bonuses. Even I can keep a clause, if the variability is less, there should be some bonus to be awarded to the contractor in that case, because he has done a lot of effort to reduce the variability. However, PW, and in general a percent within limits below 60% is normally considered for rejection. So, and in that case you have to go for a replacement of the lot. So, in that case here we can see if the percent within limits is more than 95%, that means the percentage defective is less than 4%, then in that case a bonus has to be given. It is 105% of the contract cost, otherwise in this particular case 90 to 95. So, this is a typical example which has been taken up. This has to be decided based on the projects, and it has to be well decided before the commencement of the project. Now, for the different characteristics, already our specifications gives the requirements, what are the number of tests which are to be done, what is the frequencies to be followed, like we discussed about the prime coat and tack coat application as per IRC 16. So, it says the tests which are to be done in respect to the quality of binder. So, it says one test, set of tests for a tanker of lot 10 tons as per IS 217 for cutback bitumen, and IS 73 for bitumen, IS 8887 for bitumen immersion. So, one test for a tanker has to be done of 10 tons. In that particular case, binder temperature can be regularly monitored. There is no specific frequency mentioned. Rate of spread of this prime coat or tack coat needs to be checked for 1000 square meter and not less than 2 tests per day. So, this is already well specified in our codal specifications. Similarly, we have what different tests can be carried out for the aggregates. As I mentioned, there can be soundness, plasticity index, water absorption, polished stone value, sand equivalent test, and specifically the shape and the strength related test. So, it mentions one test per 350 cubic meter aggregate for each source and wherever there is a change in the quality of the aggregate. So, if there is some change in the source of aggregate, then again this has to be done. Then quality of binders, because we will get binders, maybe your neat viscosity grade binders or modified binders. So, when you get these different grade of binders, specifically same category, grade and the same manufacturing batch is there. So, that is known as one lot, specifically that forms a lot. So, a lot is which is of the same category, whether neat binder or modified binder, same grade, VG30 grade, manufacturing batch is also same. In that case it forms a lot, and that lot tankers how much samples you will be taking. So, up to a lot of 50, 2 containers. So, number of containers are there. So, up to 50, number of 2 containers can be selected when this is for modified binder, and this is for neat binder as per IS 73, this is IS 15462. So, it says how many containers needs to be picked up specifically for these binder grades, and on these containers what are the specific tests which are need to be done. We need to, for neat binders we do absolute viscosity, penetration and softening point test, and for modified binders, polymer modified binders, the test mainly done are softening point, elastic recovery, separation and penetration test. So, these are some of the tests which are recommended by IS 73 and IS 15462. Then type of construction, as mentioned, we can work out the binder content. What as per MORTH specifications, it says that binder content should be determined at least for 400 tons of mix. One set for 400 tons of mix, subjected to 2 tests per day per plant. So, one lot 2 tests has to be done at least minimum specifically, and temperature again to be monitored regularly for your different grades of binder. And along with it, the aggregate, if there are certain aggregates where concerns are related to the fractured faces, then one test per 350 cubic meter of aggregate when crushed gravel is used, specifically because there we have the concern related to the crushed faces. The other requirement, as the 2 main parameters, one is density. So, the compaction field density, it says this is SP 112, which says that 3000 square meter, but at least limited to single day's production. So, how many samples is to be taken? 4 samples at least. And when voids in mineral aggregates, again 400 million ton, but limited to a single day's production, 3 tests. So, already these number of tests which are to be conducted on these different components of bituminous mixes is important. So, the most important thing is we are able to monitor the variability through control charts, and then we should realize this, that definitely a little amount of variability is going to exist. So, we can work out in terms of the percentage within limits, and then on the basis of this we can judge the quality of these mixes. So, this is all about for the aspects related to the quality control of bituminous mixes. Thank you so much.